Hi everybody. So my name is Alex, but you can call me Alex in double quotes. And I hear many of you asking, why would you do that? Why the double quotes? It's very simple. A long time ago, some journalists wrote about me, and they referred to me as a hacker who goes by the name Alex in double quotes. And Alex is also my real name, so this is, yeah. More recently, some journalists wrote about me, and they referred to me as a hacker in double quotes, whatever that is. So I can't wait for whatever the next version of this is. I also help out organizing a conference called Purplecon, which is a conference that instead of looking like, which is a conference that instead of looking like this, looks like this, which is a bit of a, unnecessary thing for me to say on the Kawaiicon stage, but oh well, here we are. But enough about me. Let's talk about work. Professionally, my job has been red teaming recently, and I should really explain what I mean by that, because red teaming means a lot of things to different people. It's very simple. The job is to hack the company that you work for exactly like an actual criminal would, do whatever they would do, and then share how you did it with that company because a real criminal doesn't tell you what you missed. And then finally, to sell the stolen data on the dark web for big money because that's what a real criminal would do, right? No, not really. We don't do that part. Once I did this exact slide at work and something happened with the slides and the big X didn't show up. And I was like, you have to believe me. They did believe me, luckily. So professionally, I've worked at many places, including Atlassian. Anyway, now I work at nowhere because I'm engaging in business ventures at my new business venture, mangopdf Communication, in which I teach hackers like you how to talk and write good so that the people who aren't experts understand us when we talk about stuff. And if you're wondering about that, don't worry. That makes me a professional communicator, which is what that looks like. And I will see you in 220 slides. But enough about work. Let's talk about malware. If you haven't heard about malware, it's mal meaning bad and ware meaning where. So have you ever written software so bad that you've been like, have you ever written software so bad? Hello? Yeah, okay, thank you. That you've been like, at what point is this kind of malware? Like, when is this? Hello and welcome to my talk. So you probably have heard of malware. You've probably seen it. You've probably even stopped it or detected it or something. But you might not, or you are less likely to have you actually written it yourself? Have you used it? And have you tried to keep it hidden from other people and make sure they can't tell that there's malware there? And also, have you tried to make it not attributable to you and, in fact, actually try and make it look like it's some actual criminal, not you, a red teamer? This is what I want to talk about today. So before we do any of that, I just want to get some misconceptions out of the way. What actually is malware? It's very simple. Malware is a Steam video game in which you navigate Windows installers and attempt to click next and install real software without accidentally installing malware. My name is Alex, and I recommend downloading and installing malware to your work device. Once I did this talk and someone took a picture or took a screenshot of just me and just this slide, and I was like, oh, okay, cool. But no, really the way I like to describe malware to people for the first time is it's kind of like remote control software that lets you remote control somebody else's computer. And more technically, it's kind of like SSHing into someone's computer. When I talk to software developers and I explain, well, it's like if somebody could SSH into your computer, they're like, oh, that seems bad. I'm like, yeah, it is. Why would you use malware? What's the point? What are you hoping to gain by using it? There's two reasons. The first one is to get past two-factor auth. You know, these things work. These things are effective. These things are hard to get around. And so one of the main reasons I see people use malware is to not have to try and actually authenticate using these things. So one of the most common ways to do that is, you know how people have Google Chrome on their work laptop? Well, what if you could use malware to upload that Google Chrome to your computer, stealing the cookies, and then that way when you go to some website, you're already logged in as with their browser. You don't know their password, you don't have their two-factor auth, but you're already logged in because you're still on their browser cookies. This is very popular. Hackers love doing this. So that's one reason. The other reason is the same thing, but instead of getting around two-factor auth, for getting around VPNs or zero trust or all that stuff, like network-based things. So this is an example of how zero trust and VPNs work. When you actually log into when you actually authenticate to the network, you need your email or your username and password and probably a two-factor auth thing, maybe a YubiKey and a device certificate. You need all this stuff that is hard to get. This is the hard part. And then you talk to the zero trust access proxy, which is completely different to a VPN. Don't be confused by that. then you send all that stuff to it, and it's like, yeah, okay, you can come in, that's fine, you're okay, come on in, go and get proxied to the next thing, it's fine. And then meanwhile, I'm over here being like, may I connect to the Zero Trust Access proxy? And it's like, no, you don't have the stuff, fair enough. But like, if you have malware on this person's computer, then like you can execute code on their computer. So you can be like, well, what if I just proxy my computer through their computer and go like around the world like this? And then when I send my traffic to the like access proxy thing, it's coming from their computer. So it's like, so true, that seems good, nothing wrong with that. And then you get to access the stuff. Anyway, it's good. That's why you might want to use malware, for those 2 reasons. There's other reasons, but those are the main reasons. So that's why you would want to use it. But okay, let's actually make it. And well, if you haven't made malware before, like the first time I was learning about it, I was like, oh, how do you do it? So like, what should we start with? Like, is this malware? I'm accessing someone's SSH keys and I'm like exfiltrating them or something. Is this compromise? And like, what kind of, like, you're taking their SSH key from their laptop like to their laptop, and you're like, meanwhile you're over here being like, why did I do this? What was the point of all that? So like, no, that doesn't count. That's not malware. Let's try again. Let's try again. So earlier I said it's kind of like SSHing into someone's computer. Can we actually do that? That would be really good. Like, is that possible? And then, so okay, let's try it. Let's go SSH. And then like, oh, I see the problem. Like, what do we type there? Because no one actually has like a publicly writable SSH server on their laptop. Actually, I bet some of you little freaks do have a publicly writable SSH server, and I don't want to hear about it. Okay, let's try again. Let's make malware. What if, instead of doing all that before, we put another server in between my laptop and the laptop of whoever we're hacking, and it's like, and the malware talks to that server. What should we call that? What's a good name for that? I don't know. Why don't we call it Command and Control or C2 server? Because we work in the military, and this is cyber war, and that's like a good name for this. Actually, no, let's not do that. Let's call it crimecentral.com. That seems good, or whatever domain name you want to use. And so then when the malware actually runs, it talks to that server and says, hello, what should I do? You're the boss. And that server says, well, how about you do this? How about you execute this command? And the malware's like, all right, you got it. Here you go. Here's the result of that. Happy to help. And then meanwhile, you can then connect to that server from your computer and be like, give me the goods, give me the stuff, and you can control the malware. That seems good. That seems like a good idea. This is indeed the like architecture that most malware uses. And now we're talking, right? But is that perfect? Isn't there more things about this that you might want to know? Like, I'm just saying you put malware on their computer, but where do you get this like malware, this binary that just does this for you, that does that? And like, there's a lot of places you can get it. You can write your own. There's a lot of ways you can get it. But you don't have to do the hard way if you're just starting out, because you can just download it from GitHub where everyone else keeps it. This is some random malware I found. This is one's called Sliver. To be real, this is mostly used by red teamers. I don't know how many criminals actually use this, but I'm sure some people try and use it to seem like they're actually red teamers in like a big 5D chess move. And so this is how it works. So it has like a CLI thing, and you go in there, and like there's all this nerd stuff that's not important, but the important thing is this part, where you can be like, hey, look, can you make me some malware that speaks the HTTPS protocol and talks to this server, and then some other like nerd stuff, not important what this is, don't worry about it. And then at the end, it's like, hey, look, I made you the binary, it's saved, it's all yours, go get it. And that's pretty good. We made malware. That's fun. And there it is. But I hear, talk's not over. I hear you going like, okay, you made the malware, but like, isn't the hard part like how do you actually get this malware to like be executed on someone, like to be on someone else's computer, and then they also execute it? Like, isn't that compromise? Isn't that the hard part? And like, listen, I just want to say, social engineering isn't that hard. Everybody makes a big deal about it, but you just got to keep it simple, right? Like this. I'm just saying it's simple and clean. It's going to work every time. So, assuming that works, now here we are on someone else's computer, and they've like downloaded and executed our malware binary thing, and it works. When we go to our like malware control server, the malware says, hello, I'm here. What command do you want me to execute? And we've got a connection to it. It's working. We did it. And for a lot of people, the talk would end here. They'd be like, okay, compromise. This is the thing we're all trying to prevent, right? This is like, it's over. Once the malware runs, it's all over. Everyone go home. But like, so we did it. We did that step. That's an important step. But like, what about the thing where you keep it there on their computer for like some time, and you use it to commit some sort of crime? Like people don't just go out there being like, I'm going to execute malware on people's computer and then stop and go home. Like, they're trying to do something with it. So, for example, what if this person's like, cool, I executed this malware, but now I'd like my terminal back and I need to run some more commands. So they're like, cool, that's fine, I'll just press Control-C. And you're like, oh no, I went to all that effort just for this. And so like, okay, let's try again. Let's make it better than that. We can do better than that. And I can hear it. I can feel it. I can hear you all saying, wait, no, you just got to background it. And like, yeah, you can. And like, but when you background it, like, first, it puts this big awkward number here. But it does work. They can press Control-C and it's fine. But also, if they just close that terminal window entirely, not just pressing Control-C, then it's over. The malware's gone entirely because when you run the malware, it's a child process of the bash process, even if you background it. And so when you get rid of the parent process, it also gets rid of the child one. That's how it be. So okay, maybe we can do better than that. So you have to put this. I found out you have to put this disown thing afterwards, which is kind of like saying it's not like this anymore. The bash process is like, I've never heard of that malware process in my life. I don't know who that is. And so then if you get rid of the bash process, the malware one's still okay. So that's how you make it be okay when you close it. Now when you close the terminal window, it's still okay. The malware's still running because it's all disowned. But what about this awkward number that's here? Isn't it kind of annoying that it prints out a number? What if you're trying to be sneaky about this? And I can also hear you all saying, no, you got to redirect the standard input and standard output. You got to redirect it to devnull. And you do, but this also didn't work. It still prints out the number. And I was like, what? Okay, so I'm sure there's a more clever way to do this, but I was just like, shh, and just put more devnull. I think you actually just need the brackets. You don't need the second one. But I was like, whatever. I don't need to. Shh, it's fine. And then, indeed, when you do that, it's all okay. It doesn't print out the number anymore. So now can we say, check, we've kept it there? Are we all done here? Well, not really. Because what if this person who we've compromised, they're using their laptop, and they're like, I think I'm going to restart my laptop just to feel something. Yeah. And they do. And so then you're like, cool, my malware's running, and then they restart it, and then, of course, it's gone because you didn't make it still be there when it restarts. The process gets killed. There's nothing keeping it going, and it's over. Your malware is just gone entirely. So let's try again. I'm sure you've heard of this part. This part's called persistence, where you make it so the malware keeps being there no matter what happens. Has anyone heard of this file? This is the Z profile file. It's kind of like bashrc or zshrc, but not. There's some really complex definition that's the difference between them, but I don't know what it is. So it's like that, but not. And so you could just put that whole thing from before in that file, but probably no one's going to look in there. But if they did, it's a bit like, oh, that's a bit obvious. Someone's really trying to really clumsily silence this malware in here. So let's try something else. What if you put this in here? That looks kind of more legit, doesn't it? But also, who would put that there? Why would anyone do that? And the answer is, a lot of people would do that. There's this software called NVM, and people are NVMing out there. And when you install this software, it puts literally this exact thing in this exact file, which is amazing. And by the way, NVM is I'm like, yes, I need to have NVM because I need to install an incredible number of versions of Node.js in order to secure VC funding. And I'm like, well, actually, I've got a lot of versions of, I actually kind of need a lot of versions of NVM. So what we really need is I'm using so many Node version manager versions, I really need a Node version manager. And actually, I've got a lot of versions of that, so I need a manager for, and so on, right? I don't know. Anyway, here's what it puts in there. It puts some node stuff, not important, but the important thing it does is it executes some other script called nvm.sh. And so I think what we do is you put the actual malware in that one. No one's going to look in that one. People don't even know it's in there. That's going to be fine. So I think that's slightly more stealthy if you had it in there. So now we can say, yes, we kept it there, right? Actually, no. We can't really say we kept it there. We haven't done much more than this. Because you know how, you remember this part when we're talking to the server? What if you want to hack more than one person? What if you want to have multiple copies of this malware running on multiple things at the same time? Then what if, I don't know, something happens on one of them and someone notices there's malware there and the cyber police show up, by which I mean incident response team, and they're like, hey, this machine has malware on it. Hey, who else is talking to crimecentral.com? That's an awfully suspicious domain name. And they suddenly find, oh, everyone else you've compromised, even if you compromise them in totally independent ways, they're all talking to the same domain name, so it's really easy for the incident response people to find out that they're all connected. And so does anyone see the solution to this? Does anyone see what we should do to this? That's right. The solution is to go outside and touch grass and forget any of this ever happened. No, I'm just kidding. The solution is actually redirector infrastructure. Let's talk about it. So instead of doing what we were doing before, what if we had another server in between the first server and the actual malware? And that server had some much more legitimate-looking domain name than crimecentral.com. And then it uses an HTTP reverse proxy to connect to the actual malware, which just means that you can't tell it's a proxy. When you use it, it looks like it's actually serving it by itself. And then if we have that going on, then I imagine you're wondering, wait, this new server, where do you host it? Where do you actually buy the server from? Because this is the one that everyone's going to be seeing when they, this is the one the malware's going to be talking to, so it needs to look legit. I mean, you could just do what everyone else does and, buy it on AWS, but I don't really think cyber criminals do that, because I think AWS is kind of good at being I don't know, giving your payment details to the government. So instead, you could find some other much more reputable offshore DMCA-ignored hosting provider, such as this one that I found. This one is called AlexHost. That's a coincidence. I just stumbled on this one, unrelated. So now, back to this is what we have. The thing is, you can make a lot of these redirectors. You can make as many as you want, and they're kind of easy to spin up. And you can all have unique domain names, all have unique everything. So that way, when one of them gets noticed, when one of these compromised computers gets noticed by the incident response police and it gets taken down, then the other ones are still okay. Or are they? Because didn't we do something? What was the problem with before when we had all these servers? The problem was these were all the same thing. They all use the same domain name. And so what's wrong with this is currently they're all using the same malware. And it's also really easy for the incident response people to be like, where else is this exact hash of this exact program running? And so let's go in that way. If one of them gets noticed, then okay, you get the idea. So now let's go back, regenerate more copies of the malware which have different things in them. You can make them different any way you want. Easy ways to put different domain name in them. That might make them different, but it probably will. And that way, now they'll have different hashes. So when one of them gets found, okay, you get the idea. So keeping it there, can we say we've kept it there yet? I don't know if we're ever going to check this off. Actually, no. In fact, we actually can't even say we're done with the first step, because we don't really want to execute malware for just anyone. We want to execute it for the right person. So you know how we have this situation, we have this situation, and we have all of these guys? These things are kind of like expensive to make. So you know how we're also hosting our malware up here, and like we're doing this genius GitHub social engineering thing, but like we're actually, in this example, we're just like putting the malware binary like right there, like on GitHub, like publicly. And like, do you really want to put that binary there? Because then like, if someone is like, if for some reason this genius social engineering doesn't work, they can just like click on that thing and be like, oh, that's actually just literally a malware binary, and it has all the information in it. So if they do that, if people do notice this, then they'll be like, oh, well, they'll find out exactly what malware framework you're using, or they'll fingerprint your malware somehow. They'll find out all the file names, all the different like persistence paths it has, all that kind of thing. Find out what the redirected domain name is, that's burned now, what the hosting provider you're using. And if you're trying to not get attributed, you need to change all of these things to not be the same as before, and it's really annoying and time-consuming to do that. So it'd be nice if we only gave the malware to the people who we actually want to hack, huh? And what's the solution to this? Anyone see the solution to this? That's right. It's stage payload design. Let's talk about it. In stage payload design, instead of just downloading the malware directly from GitHub, what if instead of doing that, we stop and we download a malware downloader? Now we're talking. What a conference. And this malware downloader, you download that and you execute it. Then it downloads the malware from somewhere else, from a different malware hosting server, not GitHub. And then it downloads the malware, executes it the way we've seen before. It just does the same thing as before. And what's the point of all this? Why would you do that? Isn't that kind of overly paranoid to do all that? And if you think that that's overly paranoid, you're going to think this is even more paranoid, because what if instead of just letting you download it from the malware hosting server, there's kind of not that much point to that. But you can change it so that when the malware downloader talks to the malware hosting server, assuming it's doing HTTP or something, it'll probably make some sort of request, like get/malware or whatever. And it will have to use some sort of user agent for that request. And it's very important, or it's a good idea, to make it use this exact user agent. I think this is a great one. I would be amazed if anyone would be like, if anyone knew why that exact user agent, but it's because these are the versions of Python requests library. There is no 2.30.1 version. That one doesn't exist. And so this is basically a password just hidden in the user agent field. And so you can make it so when the malware downloader talks to the malware hosting server, it sends that user agent, and the server checks the user agent and says, is that the one that I'm expecting? OK, you can have the malware. And otherwise, you can have something very normal that's not the malware. For example, maybe your malware is packaged up as a VPN client that's backdoored or whatever. Then you can make it so if they have the right user agent, they get the backdoored one. And if they don't, they get the real unbackdoored VPN client. And like the reason you want to do all this is so that only the people that you're actually trying to hack get your malware, so people who are trying to reverse engineer it, or people who are kind of suspicious, it doesn't burn the actual thing that you spent so much time working on. So check, we kept it there, right? Or did we? Because, I'm sorry to keep doing that. There's actually a lot of problems with this malware. Like, it's not really very obfuscated, or we didn't really talk about the obfuscation. And there's like no SOX proxy. We haven't talked about it. How are you going to SOX proxy in there? The SOX proxy is always a really bad and like laggy anyway. And like it doesn't run in memory. It's just on the disk. And you should probably, this Z profile thing is a bit like rookie. You should probably do something really complicated with an Electron app. And the server should be not like an actual web server. It should be hosted through CloudFront or some legit thing. And there's actually a lot of problems with this malware that there's like too many. There's too many things for me to do at the time. So like, I don't know. Like, what's the solution to this? And what's the solution to this problem? If you're watching the talks yesterday, you would already know. But that's right. It's to burn the flag and blow up Parliament and join your local union. Thank you very much.